So hello friends, welcome back to my YouTube channel Infinite Knowledge. I am back with again the simulation project of Matlab and what is the project which concept is considered here. So the it's a basically DC to DC converter which is specifically connected to the wind system. So you can see here this is a wind system, wind generator that generate a wind, that generator not a wind, that generate a voltage. And actually DC to DC converter is here. This one is a part of DC to DC converter which maintain output voltage constant, because what is a actual problem, because wind speed is not fixed. Wind speed is continuously changing. Due to continuously change in the wind speed, your output voltage is continuously changing. And to get a proper fixed output voltage, you require some DC to DC converter or any type of DC converter like buck, boost converter, cock converter. And so right now we are focusing on this model, and in which this model I have specifically used this relay. So relay is used to switch on and off these IGBTs, and actually this IGBT control our output voltage. And what is our output voltage? What is the recommended set value of our output voltage? Is 25 voltage. So I want 25 voltage at the output side continuously, and by switching on and off at this is a buck converter, and this buck converter try to maintain the 25 volt at the secondary side. This is the battery is initially 50% charged, and according to our supply voltage level it gets charged and discharged. If this second line is negative, this second line is a current of the battery current. And if it is negative, that means my battery is charging. If it is positive, that is my battery is discharging through this resistor. Again, I have two models. First one is simple by using relay turning on and off my IGBT. Whereas this one is our a PID controller, or it is a PI controller. PI controller makes switch on and off these IGBTs, and according to its a PI controller PID logic sends our output voltage and set voltage, and according to that is switch on and off, and we are getting output voltage. Similarly, the 25 voltage is our output side, and we will check both the simulation specifically, and what is the input of this wind generation. So you can see here there are different switches. These different switches have some different values. So you can see here this is our wind speed, and this is a normal wind speed. So in between 50 to 100 values, it's our normal wind speed in meter per second. And if it is low wind speed, it's a 40 means low wind speed, and 1110 it means our high wind speed. So at high wind speed also we have to switch off our generator. At low wind speed also we have to switch off our generator. Why? Because low wind speed we are not getting satisfactory output voltage, and over voltage or over wind speed also create a very high voltage, or even it's cause the damage of our wind turbine. So we are not usually using or driving the turbines at low wind speed as well as over wind speed. So here different normal wind speed condition I have created, and according to all wind speed condition we are checking the output voltage, and is does our output voltage maintain 25 voltage constant or not. Specifically this model we are follow the similar thing, and here just change the both model are same, just change this part is changed, this PID part is changed, this controlling part is changed, whereas everything is as clear as crystal. So as now there is no any switch is on. Okay, so I am switching off the all these switches. So now all the switches are in the off condition, and just I have applied first one is a 50 meter per second is our wind speed for both the system. Okay, and then I have started. So initially there is actually you can see here is our voltage. So if our voltage is low, okay, so we are getting satisfactory voltage, and due to this satisfactory voltage my battery is charging. So you can see here my battery charging is increased 50.2829. Initially it was a 50. Again for below model you can see battery is charging 50.2, 50.21, and again I am increasing my wind speed. So at now I am increasing my wind speed in the two steps. Okay, so right now it's a 70 meter per second, and at below side also I am increasing it. Again it is a 70 meter per second, not a milli per second. Meter per second is our wind speed, and you can see here voltage is increased. It takes time because the wind speed is, you can see here very clearly our voltage is increased as I have increased the switches. Okay, so it is very clear your voltage is increased and your current is changing. And here also you can see our output voltage is maintained 25 voltage constant. So you can see here, yes. So due to this change, I am getting some spike, but it is very low. The ripple is very low. You can see our output voltage is nearly 25. Okay. So why these spikes are created? Because of this switching, it continuously switch on and off, and due to LC topology, due to that we are getting slight variation in the supply, but after some time it's just constant. But this amount of ripple would be present. It's a very minimum. It's a 2498 to 2404. So I think it's a 0 point, nearly it's a 0.06 to 0.08. Okay, so our voltage variation is very low, and you can see here output voltage and the output current. So I think it is nearly DC. Similarly, we have to check for the PID controller also. Previous one was the for the switching. It is just a simple relay, and this relay just turning on and off. You can see here. You can see very clearly. This is the output. Okay, the different output. You can see the relay is turning on and off continuously, and we are getting some output voltage. Okay. Also, I have changed my value to the 70 for PID controller, and I am checking my output, which type of output that we are getting. So this is the output for the PID. So we are checking the output for the PID. Okay, so output for the PID is very clear because our voltage is right now very nearer to the specific set value 25 voltage, and also our input is nearly very, it is very near to 26.30. Okay, so that's why we are getting very clear voltage at the output side. Now again I am increased my wind speed to in the second, and I have increased to a 90 meter per second. Again I at upper side also I am increased to a 90 meter per second. So just I have increased it. I am getting some high ripple in the output. You can see there is some ripple. There is some ripple. Okay, slight high ripple we are getting, but after some time it's come to minimum. Initially my wind is changing. Just if I press this switch, it does not mean it continuously or at an instant I am getting high voltage, because wind take, as my input wind speed is changed, it takes some time to change. After some time or during that time my voltage is slightly gradually increase, so it is not increase like instantaneously. It takes some time to increase. That's why I am getting slight high variation in initial state, and then it is a minimum. So as you clearly see, high variation because my wind speed is increased, and once my fixed voltage is come, or slight fixed speed is, so I am getting this DC. This is the DC voltage. This is not a AC voltage. There is some spike. It is a slightly 25 to 20, 0.1 spike, 0.1 voltage spike. So this voltage spike will be present. You cannot remove this voltage spike. Okay, yes, you can minimal, but 0.8 voltage spike is very minimal. Again, at this moment we are checking here. You can see at here also you are getting some spike, and you can see very clearly it is trying to reduce. It is trying to reduce. What is mean? It is trying to reach at 25 voltage. Trying to reach. So after some specific time, this is the advantage of PID controller. PID controller sends the input voltage and try to reduce it and try to maintain it the 25 25 voltage. So here I have set 25 and my input. You can see here this is the output. This is actual output and this is my set value. Again at upper side also this is my actual output and this is my set value. Okay. So right now I am also increase my wind speed to the 100%. Okay, so this is the maximum wind speed for the both condition for the PID as well as this simple relay switch. Okay. So at this time, just slightly wait and checking the input voltage. This is the input voltage. You can see it's a 180 voltage. Input voltage is a very high. And here at the bottom side, also it is a nearly 114. So it is also slightly increased. You can see here, this is a voltage variation. This voltage variation come because we are randomly switching on and off different. And as I am changing the switches, my voltage is changing. You can see here, okay, my voltage is changing, my current is also changing. So this is the input part, and actually this is the output of our wind generator. And we are checking like does our voltage is fixed or not. So it is nearly 25, so I think it is also very fixed value. Okay, so you can see here my output is nearly 25 voltage. Yes, there is some spike, but spike is very minimal. If you zoom in, you will not, you will get to know about it. There is a spike in just 0.1 to 0.15. So this is a DC voltage, this is not an AC voltage, or there is no any major variation. Again, at the bottom side also we are checking for the PID current. Okay, you can see very clearly previously our voltage is very high or more than 25, and PID tried to damping it and try to reach near to 25. I think it reached near to 25 and maintain our voltage as near as possible. Also, yes, there is also some spike in the PID and 0.2. So where voltage variation is 25 to 25.2. So there is some variation in the voltage, and that is just a 0.1 to 0.2. So this is how you can make a PID controller for this one, and relay module for this one. So there is two different circuit. Okay, simple is for relay and this is for the PID controller. Both are compatible and both are maintain voltage over output side. Uh, okay, and these are different switches. If I increase my switch like over wind speed, you can see our output is, or our input of wind speed is 0. Okay, so as it come to 0, you can see our voltage is reducing. It takes some time to reduce, and after specific time, initially my battery is charging, minus mean battery is charging, but my current voltage, input voltage stay, because whenever you stop the wind turbine, it's not drastically stop. It takes some, wind turbine takes some time to stop. So here wind turbine taking some time to stop, that's why my voltage is reducing. And if my voltage is reducing, my right now battery is charging, but when input voltage is come to less than 25 voltage, my battery is discharged through this resistor. Again here also I am switch off or increasing over wind speed condition. You can see here my voltage is now try to reduce. Okay, so battery is, my turbine is in the off condition. So okay, this is upper one. Okay, so it takes some time to reduce the voltage because it's a very high voltage, and right now there is no any input. You can see here this is a wind speed, it is also reducing. For bottom one, you can see speed of the wind turbine, it's not a wind speed, it's a speed of the wind turbine. These both are the speed of the wind turbine. So you can consider you have applied a brake when this, you can see here at this position also your voltage is very fixed, because your input is continuously changing even though you are getting 25 voltage. Okay, so for bottom side we need to check output voltage. What is the effect? Yes, there is some high variation compared to upper one. PID try to maintain it, so that's why it's causing some high variation, but it is also very minimum variation. This 0.1 to 0.5. Okay, so we should wait to reduce the speed as minimum as possible. We cannot do anything. So you can see here our voltage is very nearer to 30, and at this moment also my battery is charging. Just focusing this minus sign, if my voltage is reduced, then my battery stops charging and discharge through this resistor. Okay, you can see the current is now positive. Positive means battery is discharging, and you can see just by this charge also after some time this is reduced. Okay, the simulation is stopped, the time is stopped. Okay, so at this condition also, so what is intention of it? You can see at the time of stop there is some slight variation, but this variation is happen because our output voltage is totally zero at this moment. at this moment. Okay, so the battery voltage is available. Okay, and for upper one, yes, this variation, it means your out input. This is major variation. This is a major variation. This means your input is less than 25 volt. At this condition also we have seen this major variation. Okay, so this is how you can make your own model. And actually this is a very useful, this is a buck converter, but you can make it for the boost converter also. And I am also trying to make buck boost converter, yet I don't get a satisfactory output. But once I will get it, I will put a video. And if you want this model, specifically this model, that is available in the description box. Yes, obviously there is some minimal charge that you have to pay for this modulation, for this module, for this circuitry. And I think it is a very clear and very useful project if you are thinking about to consider any renewable project. And this converter is also very clearly working, as you can see here. You can get output voltage very near to your set value. You can set any value and you are getting respective output according to it. Okay, so I have considered for overspeed. Again, for low speed also the similar scenario was created. Your output is zero, your input is even speed input is will be zero. And actually this logic is used to check these switches, or to monitor these switches. According to this switches condition, this logic is working. And I think all the things is very clear. Thanks for watching this video. If you want this simulation, that is available in the description box. If you want any type of Matlab project that I am working with you, then also you can connect with me with my email ID, that is also given in the description box. For any type of Matlab project, for any type of Proteus, or even any type of hardware project, Arduino project, you can connect with me just by email ID. Thanks for watching this video. If you have still any query, just comment it. I will definitely reply. Again, thanks for watching this video.